Okay, let's continue on. Number 21. So 21 is says for each deposit, find the future value. That is the final amount of the deposit when compounding annually, semi-annually, and quarterly. So it's basically the same problem. We just change a few of the numbers. So what we have is the principal is 2,000 in all cases. The rate is 4%, which is 0.04 decimal. And the time is 3 years. So what I'm going to do is make up a table here, and I'm going to put four rows, and let me see what I want here. I think 5. There's 6. If I have an extra one, that's fine. So what I'm going to have is I'm going to have the different terms. So this column is terms. So you have year, then you have, which is annually, semi-annually, quarterly. And so we have the same principal, we have the same rate, we have the same time. Now, the other things we need are M, which is the number of periods per year. So yearly, annually is 1, semi-annually is 2, quarterly is 4. The number of years is the same for all of them. The rate is the same for all of them. And the principal is the same for all of them. And the one last piece we need is N, which is T times M. So we have 3, 6, 12 compounding periods. The formula we use for present value is the principal times 1 plus the interest rate divided by M raised to the N power. So we just have to do that for the 3 cases. So for yearly or annually, we have $2,000 times 1 plus 0.04 divided by 1 to the 3rd power. And I'm just going to do them all, set them all up first, and then we'll just do the calculation after that. So here we have $2,000 times 1 plus 0.04 divided by 2 to the 6th power. And then quarterly, we have $2,000 times 1 plus 0.04 divided by 4 raised to the 12th power. And these all should be, pretty close. Of course, greater than 2,000. So the first one is 1 plus 0.04, which is 1.04 raised to the 3rd power times 2,000. And I get $2,249.73. Next one, I take 1 plus 0.04 divided by 2. That's 1.02 raised to the 6th power times 2,000. Should be a little bit bigger. $2,252.32. And the final one is 1 plus 0.04 divided by 4 quarterly. That's 1.01 raised to the 12th power times 2,000. And again, it should be slightly bigger. $2,253.65. So you can see we get more as we compound more frequently. And they don't ask us to do it, but if you did it compounded continuously, you would say the amount is the principal times e to the RT. So you take $2,000 times e to the 0.04 times the time, which is 3 years. And again, it should be even higher, but even less so. So if you take e to the 0.04 times 3, which is 0.12, you get 1.1275 times 2,000. And again, it should be slightly bigger. 225299. It's actually, I knew I made a mistake because I looked and it wasn't greater, so I looked back at my calculator. $2,254.99. Okay. The next one, so that was 21. 25 says, occasionally a savings account may actually pay interest compounded continuously. For each deposit, find the interest earned if the interest is compounded semi-annually, quarterly, monthly, daily, and continuously. So it's very similar to what we just did. I'm not going to have all the columns here. I'm going to have, how many different options? We have 5 options, so I need 6. And then I'm going to put number of compounding periods, the total number of compounding periods, not per year, but total, and put the answer in that column. So it's a little bit abbreviated. So this is going to be the term I get. Well, the term is actually compounding period frequency, compounding. Okay, so we have annually, or now actually start off with semi-annually, I guess. Semi-annually. So this is semi-annually. Then we have quarterly. Actually, I think I missed out one column here. No, I think it should be okay. Monthly, daily, continuous. Okay, so the number of compounding periods per year, semi-annual is 2, quarterly is 4, monthly is 12, daily is 365, continuously is infinity. Then what we have is we have n, and 25, problem 25, says it's for 4 years. So we take this number times 4, so we'll get 8, 16, 48, and 4 times 365 is 1,460. And this is infinite again. We use a different equation for this last one. And so the final amount is like that. So I'm going to do the first one, and then you're going to do the next 3, and I'll write down the answers, and then you can confirm that you did it correctly. And then we'll do the continuous one using a different equation. So remember, the equation is the present value is equal to principal times 1 plus the rate over m to the n power. So our first case is we have, and again, principal is $850. Okay, so let's go back here. Where was I? Oh yeah, the principal was $850. So P is $850 times 1 plus the rate, which is what is the rate? 1.6%. So that's 1.6%. So that's 0.016. And semi-annually would be 2, and n would be 2 times 4. I already wrote them all down here, so that's the 8th power. So all you have to do, and to do all the rest of these, is you just have to change these 2 numbers. So it'll be 8 and 2 8 and 2, 16 and 4, 48 and 12, and so forth and so on. So at least for the first case, let's see what we get. Shouldn't be that much because the interest rates are really low. So 850 times 1 plus 0.016 divided by 2. The whole thing raised to the 8th power. Oops, something's wrong. Oh, I see what it is. I get $905.95. Now, we're going to skip to the continuous compounding. There, the present value is P times E to the RT. So our principal is 850. We take E raised to the R, which is 0.016. That's your yearly rate times the number of years, which is 4. And this should be greater than that. And all the other numbers should be between these two. The smallest one is the first one, and the biggest one is the last one. So I get $906.18. So I'm going to write these up here. So you've got 905.95. Here you got 906.18. So I'm going to put it on pause, and then I'm going to write them all down. But you go ahead and finish them off. So hopefully you got those answers. You can see they all are between the original value and the final value. There's only, what, 18 plus 5, 23 cents difference between the two, all of these. So once you get to daily, daily's pretty much the same as continuous. Okay, so that's 25. And what do we got next? 29. So 29 says, found the amount borrowed in simple interest loan. What is the maximum amount Ginger Logan can borrow today if it must be repaid in 4 months with simple interest at 8%, and she knows that at the time she will be able to repay no more than $1,500? So you can work it back from the equation we had earlier for simple interest, which said the amount that you have to repay back is the principal plus the interest. But the interest is just equal to the principal times the rate times the year. So you can factor out the P. So you have P times 1 plus RT. So when you factor, it means you divide each one of these by P, and then what you have left you put inside the parentheses. So in our particular case, T is equal to 4 months out of 12 months. So that's in terms of years. T is always in terms of years. So that's 0.33 years. The rate is 8%, so it's 0.08. Again, remember, we only do calculations with decimals, never with percents. And she knows at the time she will be able to repay no more than $1,500. So in this case, A is $1,500. So you can plug the numbers in and then solve, or you can solve it for P algebraically. So to solve it for P algebraically, you would divide both sides by this term in the parentheses. So you get A divided by 1 plus RT. And now we know everything. So she can pay back $1,500 after 4 months. Her interest rate is 0.08%, or 0.08 or 8%, and the rate is 1/3, or the year is 1/3 of a year. So I put it as a fraction, just because that way I'll get it. I won't have to round off any my calculator. So I get 1,500 divided by 1 plus 0.08 times 1/3. and I get $1,461.04. So what that's saying is that if she borrows, the way looking at it, if she borrows this much, she'll have to pay $1,500 back in 4 months. Okay, 29. That was what we just did. 33. Find the present value for each future amount. So it's kind of the same kind of deal. So you have to go the opposite way. And so what it says is the future amount, so this is 33. So A, in this case, the future amount is $9,860. It says we have 8% semi-annually for 10 years. So that's not 10, it's 20, because N is, so 10 years T is 10. So we'll put T in here. T is 10, so N is these two multiplied together, which is 20. So what's the equation? Well, the equation says the present value is the principal times 1 plus RT, pardon me, R divided by M to the N power. So we could do it algebraically, but actually it's probably easier just to plug the numbers in and then do it from there. So you get 9,860 is equal to P, which we don't know, trying to figure out. 1 plus the rate, which is 0.08 divided by 2 semi-annually raised to the 20th power. So we can do that calculation in the parentheses. So you get 1 plus 0.08 divided by 2 raised to the 20th power. And so I'll get 9,860 is equal to 2.1911 P. So this part becomes 2.1991. So P is equal to, put some dollar signs here, 9,860 divided by 2.1911. And I get $4,500. My actual book says $4,499.98, or 4 cents difference. I wonder why they would have gotten that. Let's say, no, I just may not have carried out enough decimal points. Let me just try it here. I did something wrong there, didn't I? Okay, let me try it all again. 1 plus 0.08 divided by 2, that's 1.04 raised to the 20th power. Take the reciprocal of that. 0.463, okay. Multiply that by 9860, and I get, yeah. So they were right. I rounded off too much. 499.98. So that's the present value. Present value is what you start with. The future value is what you end up with. Okay, how many more do we have left? 3. I'll just keep going here. 37. Okay, let's read it. Find the present value of the compound interest retirement account. So this is very similar. It says somebody, Robin Mart, wants to establish an account that will supplement her retirement income beginning 30 years from now. Okay, so 30 years from now means T equals 30 years. For each interest rate, find the lump sum she must deposit today. That's the present value, so that $500,000 will be available at the time of retirement. It's kind of like the one we did with the $10,000 and keeping it in for so many years, except we're going the opposite direction. So let's read this. 37 is, the interest rate is 0.05 compounded daily, so M is 365, and so N is going to be 365 times time, which is T. Let's get that. It's a big number. 365 times 30 is 10,950. And again, what we have is the principal is equal to, or the future value, A, is equal to principal times 1 plus the rate divided by M to the N power. So we're just going to plug in what we have. And again, the future value is $500,000. So we have 500,000 equals P times 1 plus the rate, which is 0.05 divided by M, which is 365 to the 10,950th power. So let's do the print. In parentheses, we have 1 plus 0.05, divide 0.05 by 365. So we get this 1.000136986. Okay, raise that to the 10,950th power. So we get 500,000 is equal to P times 4.481222869. So we divide 500,000 and we get $111,576.54, which is correct. Okay, what's next? 41. So 41 says find the effective annual yield. So remember, the yield is equal to 1 plus the rate divided by the number of periods raised to the number of periods in the year minus 1. So it says suppose savings loan pays a nominal yearly rate, which is R, 0.02 or 2% on savings deposit. Find the effective annual yield. And we are compounding quarterly. So M is equal to 4 for quarterly. So the annual percentage rate, if we did that in class, is 1 plus 0.02 divided by 4 to the 4th power minus 1. So you take 0.02 divided by 4. That's 0.005. You add 1, 1.005, raise to the 4th power, and you subtract 1. So what we get is 0.02015. That's the effective rate in decimal form. If we just move the decimal point 2 places, we get 2.015% effective. And is that the right answer? 2.015. Yep. Okay, one more, which is 49. Find years to double. How long will it take to double your money in an account paying 4% compounded quarterly? Answer in years plus days, ignoring leap years. So we're going to come up with a year plus a decimal number. We'll have to compare decimal to days. So again, what we have is the present value is equal to the principal times 1 plus the rate divided by m to the n power. And what they're asking for is how long does it take for a over p to be 2, meaning we're doubling our money. So we know that therefore 2 is equal to 1 plus r over m to the n. Now n is equal to m times t. That's what we're trying to find, time. So m is, what is m? I think it said quarterly. Yeah, quarterly. So m equals 4, because there are 4 quarters in a year. So if we put 2.0 is equal to 1 plus 0.0, let's see, interest rate, 4%, divided by 4 periods per year, raised to the 4t. So we have to solve for t somehow. So let's, which I'm not sure I know how to do it using logarithms, I think. Let's see what happens. So we take 1 plus 0.04 divided by 4. So we get 2.0 is equal to 1.01 raised to the 4t power. I'm just going to check here. Like I said, I know how to solve it using logarithms, but you guys don't know about logarithms. So let's see what the other way is. So this is 13,149. 13. Oh, okay. These logarithms. Okay, so we definitely want to have something like this on the test, but I'm just going to show how it works. So what you do is there's such things called logarithms, and what you do is you take the logarithm of both sides of the equation. So, you know, the equality property says if you do the same thing to both sides of the equation, you end up with inequality. So one of the properties of logarithms is that if you have an exponent, you can bring that out front. So this, instead of being an exponent, becomes a multiplier times the number. So we can plug in, we could figure out what these are, but I'm actually going to solve for t. And so to solve for t, I need to divide by 4, and I need to divide by the natural log of 1.01. So you get the natural log of 2, which is on the left-hand side, divide by 4, and divide by the natural log of 1.01. Okay, so here we go. Plug it in natural log 2 divided by 4 divided by the natural log of 1.01. And I get 17.415 years. Okay, so they said they don't want it, they wanted years and days. So what we have to do is take the decimal part and multiply by the number of days in a year, which is 365.415 times 365 is 151. And actually we have to roll it, round it up to 152. So the answer is you have to have it in for 17 years. And the equivalent of 0.415 years, which is 152 days. And then if you had it in another 17 years, you'd double it again.